So first step here is to sort this out into a form where we can integrate nicely. So over here we got 12x cubed plus, now when I take the root x to the top, it's going to become x to the negative a half. It's still over 6 though. Minus 3 x to the minus 4, and that's still over 2. And that's why I just have to be careful that I don't move those numbers. I'm only moving the letters. So integrating, we add 1 to the power, divide by the new power. We add 1 to the power, divide by our new power. Add 1 to the power, divide by our new power. And don't forget our plus c. Then it's a matter of essentially sorting this out, simplifying it. So 3x to the power 4 plus x to the half over 3. Now if I look at this one, it's going to give me minus 6 on the bottom, and that 3, the 3 will cancel nicely, even though it's just 2 on the bottom, but it's a minus, and that minus is going to give me a plus. So we've got plus x to the minus 3 over 2 plus c. Now that will give me the full marks, but as I've said in previous videos, I like to leave it in the same form if I can as what was in the question. So that would be putting my x to the power of half in the root and putting that x to the minus 3 then onto the bottom. First question done. So in this one we are looking at something to do with a gradient, so that means we need to differentiate. So if I differentiate this, I get, so I need to multiply by the 5, so it's going to be 15x, take 1 away from the power, plus multiply by 3, multiply by the power, take 1 away from the power, minus 1, and then the 5 will go. Now it says that the gradient at both points is 2, so that's telling me that dy by dx is equal to 2. So I know that 15x to the 4 plus 12x squared minus 1 equals 2. So 15x to the 4 plus 12x squared minus 3 equals 0. What I'll notice straight away is that each of these terms have 3 as a factor. So let's divide through by 3 to make our life a little bit easier. And now it's essentially like dealing with a quadratic. So if you think of it this way, if it makes it any easier, if you think that, say, y was x squared, you'd be dealing with 5y squared plus 4y minus 1 equals 0. And I know you know how to factorize that or use the quadratic formula to solve. So it's not too difficult. So that is an option. I'm just going to go straight in with it in terms of the x squareds and x to the power 4s. So we've got 5x squared and x squared. That's going to give me my 5x to the power 4. We've got to have 1 and 1. We want this one plus and this one minus. That gives me my 5x squared. Sorry, 5x to the power 4. 5x squared take away x squared is 4x squared and minus 1. So now I can see that 5x squared minus 1 equals 0. 5x squared equals 1. X squared equals 1/5. Or x equals plus or minus root 1/5. When I look at the other one, x squared plus 1 equals 0. X squared equals negative 1. And then I cannot take the square root of a negative number. I mean, I can in terms of imaginary numbers, but that's in further maths. So that I stop with. So we've got that our x is root 1/5 or negative root 1/5. Now we only need to define the x coordinate of P and Q, so we're done. Okay, question 3 here. Now, when you look at this one straight away, it's very tempted to go, right, well, I'll just multiply by x, divide by 4, and I'm done. But that's not the case. Okay, because in this type of question, when I've got an inequality, if I'm multiplying or dividing by a negative number, that affects the inequality sign. So if I'm multiplying by this x, I don't actually know if that x is positive or negative. So what I actually need to do is multiply by x squared. That I can guarantee is then positive. So I would multiply both sides by x squared. So that will give me 3x and 4x squared on the right. Now what I can do is take my 3x to the other side, take away 3x. I can look to factorize out x, and that would then give me 4x minus 3. And then we can see that we have two possible scenarios here. Now these are going to be our critical values, and we're going to assume that it equals to 0 rather than looking at the inequality sign. Now this is for our critical values. So we can see that x is going to be equal to 3/4, and x equals 0. Now, since if I go back to the original, this was an x squared graph, we'll go with positive x squared through 0 and through 3/4, and we want it to be less than 0. So we want this section here. So what we're actually looking at is where x is greater than 0 but less than 3/4. And that is then the first part done, so part 1. Okay, part 2 looks a little bit harder than it probably is. Now where we want to start is at this intersection point here. We know this curve, we know the equation of this curve, so let's find the 2 points where it hits the x-axis. So when y equals 0. So we have y equals 2x squared minus 50, and when y equals 0, that's 2x squared minus 50 equals 0. So 2x squared equals 50, x squared equals 25, x equals plus or minus 5. So now I can see that it's minus 5 at this point and positive 5 at this point. Now my line L we know is a gradient of 3, but we don't know that C, but now we know that when y is 0, x is minus 5, so we know this coordinate. So I can substitute this in. 0 is 3 dots of minus 5 plus c. So that's going to be minus 15, so c has got to be 15. So therefore L is going to be y equals 3x plus 15. We now have the equation of that line. Now all that's left is to define the region with inequalities. So first let's have a little look. Now if we're talking about this curve, we want less than the curve, below the curve. So we want y to be less than 2x squared minus 50. And that will give me everything below the curve. Okay, so it'll give me everything underneath that whole curve. Then I want everything that is above the line. So y is greater than 3x plus 15. And that'll give me everything above the line. Now that does lead us to a little bit of a problem, because if and I'll do this in red so you can see, if I look at this area here, this is both below the curve and above the line. So these two inequalities on their own are not going to fully define the region. We need a little bit more. Now we know it needs to be on that point less than -5. So let's add that one in as well. So x must be less than -5. Now I check my graph again. Is there a region on my graph that is both below the curve, above the curve, and less than -5 that doesn't fit? So looking around, above this line and below this curve is only these two sections, and then less than -5 will make it sure it stays in this section. So this now should be my region defined, and I'll get rid of those to avoid the confusion. So there it is, 3 inequalities. And then finally, there's no dashed lines, there's no obvious that it doesn't include being on the line, so I should also really include an equals with all of these. So we've got y is less than or equal to 2x squared minus 50, y is greater than 3x plus 15, and y is less than or equal to -5. Okay, so here we're looking at finding the points Q and R. Q is that minimum point, so we know that the y value of Q is going to be -1, and normally that bottom value happens at 180 degrees, but since we have a 2x, it's going to be half that, so it's going to happen at 90 degrees. And we know it's degrees because there's a little degrees sign next to or above the x. Now, as I follow the graph, that's the point where the first kind of revolution happens. So up to that point would be 180 degrees. And this would normally happen then at 450 degrees. But in this case, we're dividing it by 2, so it's happening at 225 degrees. So point R is 225, 0. That means for part 2, my value of K is equal to 225 degrees. Now for part B, it tells me that there are exactly 2 solutions. So if I look at it carefully, for example, a line across here would give me 1, 2, 3 solutions. A line along the top here gives me exactly 2 solutions. And then a line here, all of these would give me exactly 2 solutions, except for if it hits that very bottom there. So I'm looking at essentially this point here, which I've put in blue, and then anywhere between the dashed black line and the x-axis will also give me exactly 2 solutions. That means my answers are p equals 1 and p is greater than 0 and less than -1. And that will give me everything in this region where there are 2 solutions. Obviously on this line is 1 solution, on this line there are 3 solutions, so between the 2. And that there is my answer to part B. So first things first, we know that L1 is 3y minus 2x equals 30. We want to make this y equals, so 3y equals 2x plus 30, or y equals 2/3 x plus 10. And we do that because we can see that L2 is perpendicular to L1. So if we think about perpendicular, the gradient would be flip the gradient and change the sign. So when I'm looking at L2, its gradient is going to be -3/2. And we know that it passes through the point 24, 0. This means I can work out the equation of this line. So y minus y1 equals mx minus x1. So y minus 0 is -3/2 x minus 24. Now we would often multiply by the 2 on the bottom here and end up with an equation like the top one, my preferred form. But in this case, as we are going to be looking at where they meet, it's easier to leave it in the terms of y equals mx plus c. So y equals -3/2 x plus 36. And that there is my equation for L2. Now for them to meet means that they have to be equal. So we can say that 2/3 x plus 10 equals -3/2 x plus 36. Now I'm going to multiply through by 6 just to make my life a little bit easier. And that then gives me 13x on the left and 156 on the right. Divide them by 13 and I get that x equals 12. Now I've got the x coordinate, I just need to substitute it in to one of my equations to find the y coordinate. So I'm going to use the original L1 equation here, but you don't need to. It doesn't really matter. So we get 3y so the coordinates of P are 12, 18. Now L1 meets the x-axis at B. So you think of L1, which was 3y minus 2x equals 30. It's going to hit the x-axis when y is 0. So when y is 0, we get minus 2x equals 30, x equals -15. So the coordinates of B is -15, 0, and we know the coordinates of A is 24, 0. Now it helps if you just did a very rough sketch here. Think of B is along here, -15, 0. A is also on the x-axis, it's 24, 0. And then P is somewhere up here in the positives. And that is essentially my triangle. Now, I know that this is -15 and this is 24. That means that this base has a distance of 39. We also know that this height, since it's 12, 18 is the coordinates of P, is going to be a height of 18. That means the area of my triangle BPA is going to be equal to is a half times base times height. So it's going to be a half times my 39 times my 18, or 39 times 18 divided by 2. And this is going to give me 351 units squared. And there we have our area. So part A, we need to sketch C. First thing I want to do is a set of axes, and I also want to think about what these points are here. So x plus 1 means that x is going to be at -1, and x minus 3 would be at x equals positive 3. Okay, well actually I'll do it in a little bit more detail. We have 2x plus 1 x minus 3 squared, and it's going to cross the x-axis when that f of x is worth 0. So that means I have x equals minus 1, x equals 3, and I think of that as twice as it was squared. What that means is that it will touch the x-axis but not cross it. So very, very simple little sketch here. We're going to cross at minus 1, and then we're going to touch somewhere around here at 3. It's a positive x squared, x cubed, sorry, if you multiply them together. So shape wise, coming from the bottom, it's going to go up, going to come round, it's going to touch at 3, and then it's going to go up again in the positive direction. Now I also need to find where it's going to cross that y-axis, and to do that I need to look at my numbers. So we got 1 here, we got times by minus 3 squared, so minus 3 times minus 3 is 9, 9 times 1 is 9, so normally it would cross at 9, but with the 2 here means it crosses at 18. So this point here is 18. And there is my quick sketch for C. Now part B clearly wants me to expand my brackets. So we have f of x equals 2x plus 1 x minus 3 squared. So let's deal with the x minus 3 squared first. So a quick way to expand these brackets: square the first, square the last, double the product. So x squared minus 3 squared is positive 9, and the product is minus 3x, so doubled is minus 6x. That's nice and easy. Now what I want to do is I want to multiply everything by x and then everything by 1. I'm just going to leave that 2 to last. So multiplying by x, I get x cubed minus 6x squared plus 9x, and then multiplying by 1 gives me x squared minus 6x plus 9. Now I need to multiply everything by 2 and simplify, or I can simplify first then double everything. So let's actually simplify first in this time. So we got a negative 6x squared plus x squared, so it's going to be negative 5x squared. We've got 9x, take away 6x, so it's going to be positive 3x, and then we've just got the plus 9 at the end. So this then leaves me 2x cubed minus 10x squared plus 6x plus 18. And that is my f of x. Of course you can also write what the a, b, c and d are. So a is 2, b is negative 10, c is 6 and d is 18. But that's not necessary to get you the marks. You've already got them from your f of x. Now part C, we need the equation of the tangent to C at the point where x is 1/3. So first we need to differentiate. So multiply by the power, take 1 away from the power. Multiply by the power, take 1 away from the power. So we end up with 6x squared minus 20x plus 6. Now when x is 1/3, so we got 6 lots of a third squared minus 20 lots of a third plus 6. And this equals 0. That's unusual, isn't it? So gradient of 0 means we get a horizontal line. So what we actually need to do now is find out our y value. So to do that, we need to go back to the original f of x and substitute 1/3 in. So we've got 2 lots of 1/3 cubed, minus 10 lots of 1/3 squared, but 6 lots of 1/3 plus 18. And this is 512 over 27. So y equals 512 over 27, or y equals 18.96 to 2 decimal places. Very unusual question, that one, part C, or certainly answer. Okay, so let's start by putting some values on. So OA and OC are both 0.6. AB and CB are 1.4. Angle OAB, so that's going to be 2 radians, both of those. And then we've got the theta already shown for us. Okay, looking at part A, we need to find this theta over 2. And what makes it a little bit difficult is where my sides of things are. So what I'm going to do here is I'm going to find the side OB. Just going to call this X. That's the side I want to find. And then I can find that using the cosine rule. So cosine rule is a squared is equal to b squared plus c squared minus 2bc cos a. And then when I work this out, we'll just jump straight through and I'll square root it as well. At 1.74 to 3 significant figures. Now store this in your calculator, because you want to use that full value moving forward. You do not want to be using a rounded value. Now I'm going to use the sine rule. So sine of theta over 2 is going to be over 1.4, and sine of 2 is going to be over my value of x. So theta over 2 is 0.822. Carrying on, multiplying by 2, then gives me 1.64 to 3 significant figures. Okay, you can put a few more values in first if you want to before you round off, just to kind of show that you have worked this out as well. If you want, it makes no difference. I'm not sure if there was a quicker way to get to that answer. If there are, just let me know in the comments, as I would be curious to know. But I think in the exam, under the exam pressure, this was how I would have solved it first. Next, we need to find the perimeter. So the first thing we want to do is find the arc length. So the arc length is going to be r theta. Okay, but don't confuse that with our theta, as it's going to be this major arc around here. So it's actually going to be 2 pi minus our value of theta. And the radius is going to be 0.6. So we got 0.6 times 2 pi minus our 1.64. And that gives me an arc length of 2.78 meters. So my perimeter is going to be my 2.78 meters, get rid of the meters there, plus 1.4 plus 1.4. So that's going to be 5.58 meters. It wants it to two significant figures, so 5.6 meters. Now finally I need to find the area, so let's find the area of the major sector first. So the area of a sector is a half r squared theta. The major sector would be a half times 0.6 squared times 2 pi minus our value of theta, that 1.64. Again, just make sure you use the full value in your calculator, and that gives me 0.835. And often I'll store this as a letter in my calculator, and I'll often just make a little light pencil mark what letter I stored it as, just so that I remember. Now I need to find the area of the kite, and the easiest way to do this is to find the area of one triangle within that kite, as in triangle, say OCB, which we already used earlier. So if I just do a very quick sketch of OCB, we have two sides and the angle between them. So that means we can use a half AB sine C. So half times 0.6 times 1.4 times sine 2. And that will give me 0.382. Now we actually want two triangles, don't we, for the kite? So we need to times that by 2. And that gives me 0.764. And this is area of the kite. So total area is my 0.835 plus my 0.764. And again, I'm just using the full values from my calculator. And that will give me 1.5988 and so on. And then we went to two significant figures, so 1.6 meters squared. I've talked a bit about keeping the values in my calculator. It is important because if you don't, you're actually introducing a small rounding error in all of your calculations. And the earlier that is introduced, and then all subsequent calculations then will be slightly off, and the further you use that into what you're doing, the larger the difference your final answer will have. Okay, in this case, final answer was two significant figures, so if you've done them to three significant figures or better, you should be okay. But just for you to be aware, use your calculator, use the storage functions within your calculator. So first A part 1 is essentially asking us to complete the square. It wants us to write 4 plus 12x minus 3x squared in that form. Now, as it stands, we've got a negative 3x squared, which does often make our life a little bit harder. What I prefer to do is factorize out the minus sign. So I'm going to leave the 4 over on the side, and I'm actually going to factorize out minus 3 out of the x squared and out of the 12x. So what I've done is I've just taken these two and I've taken a minus 3 out. So you can see minus 3x squared minus 3 times 4x minus 4x will give me positive 12x. Okay, now what I'm going to do is complete the square for that bit. So I'm leaving the minus 3, I'm just going to put some big square brackets in, and inside is where I'm going to complete the square. So this is going to become x minus 2 squared minus 4, and that's when I complete the square of just what was in this bracket. Okay, so x minus 2 all squared minus 4. now I'm going to expand my bracket, so I get minus 3x minus 2 squared plus 12, and then I've still got that plus 4. So 12 plus 4 is 16, so we get 16 minus 3x minus 2 squared. And there we have it now in the form a plus b x plus c. So you can see that a is 16, b is minus 3, and c is minus 2. Hence or otherwise state the coordinates of M. So M will happen at a turning point. Okay, so in this case, the largest value is going to be 16 when this is 0. So our y value is 16 and our x value is 2. Because when I substitute 2 in here, this becomes 0. Therefore we get 16 minus 0, which is going to be the largest value, 16 there. If x is anything, this will be anything in here like 1, 2, 3, apart from 2, sorry, 1, 3, 5, whatever. This is going to be positive, times by negative will be negative, which still will be a number less than 16. So it won't be this maximum point M. Alternatively, I could have differentiated. I'm going to put that underneath, but you wouldn't bother differentiating because you've already had to complete the square. But if for some reason you couldn't complete the square or you messed up, you might have differentiated this and made it equal to 0. And once you get your x equals 2, you just substitute that back into the y. So you get 4 plus 24 minus 12. And that is your 16 there for y. So you can do it by differentiating. That's your like otherwise, but hence use the first bit. As long as you've found the first bit, you're fine. If you've got plenty of time left in the exam, you could differentiate to check your answer if you wish. Okay, part B is interesting. So we can see that L2 is what we want to find, and it's parallel to L1. So all we need from L1 is the gradient. So we know that the coordinates are 2, 16 and 0, 0. So let's find the gradient of L1. So the gradient is the difference in my y's divided by the difference in my x's. So the difference in my y's, 16 minus 0, difference in my x's, 2 minus 0. So we've got a gradient of 8 here. Now, that means L2 is going to have a gradient of 8, but we need to find a coordinate for it. If I think about the diagram, I can visually see that L2 is probably going to look something like that, just touching the curve C. But where does it touch the curve C? Well, if it touches, it means it's a tangent. And since we know the gradient is 8, that would mean that the gradient of the curve at that point will also be 8. So we actually do need to differentiate the curve in this case. So we know that y equals 4 plus 12x minus 3x squared. Differentiating this will give me 12 minus 6x, and I need to make this equal to 8. So that means that 6x is going to be equal to 4. X is 4 over 6, or 2/3. Now I found out x, I need to find out y. So y equals 4 plus 12 lots of 2/3 minus 3 lots of 2/3 squared. And that gives me 32 over 3. Now I have my x, you can see up here, and my y. I need to find the equation of this straight line. Okay, so we know that m equals 8, and we know that it passes through 2/3 and 32 over 3. So y minus y1 equals mx minus x1, equation of a straight line. So that is y minus 32 over 3 equals 8x minus 2 over 3. So y minus 32 equals 8x minus 16 over 3. So simplifying that gives me y equals 8x plus 16 over 3. Alternatively, how I could write it is multiply by my 3 and then rearrange to make it equal to 0. This is probably a nicer way of writing it at the end, but I probably wouldn't mess around too much in an exam, just in case making a silly mistake. Okay, so question 9 wants us to draw y equals f of 2x and y equals f of x plus 3. So I'm just going to jump on to the diagram that they give us. Okay, let's start with y equals f of 2x. So it's inside, so it affects the x values. It's multiplied by 2, and we need to always do the inverse when it's inside. So we need to divide the x values by 2. So that means this 9, 3, this coordinate of p, would actually happen at 4.5, 3. So we want it roughly halfway between. So that's p, and it's 9 over 2, 3. And then what we want to do is kind of each point needs to get there in half the time. So what you want to do is think of, right, this one's here, roughly halfway along this line, and then put a little mark and join them up. And this will be my y equals f of 2x. Now I could probably keep it going, but since that's how far we need to go, and while we can assume that keeps on going, since it doesn't, I'm sure it should be fine to do it to this point. Now our second graph is f of x plus 3, so that means it's going to move up 3, which luckily we can see this value here, which will help us. So the first thing I would suggest doing is getting your pencil and drawing a faint line through that point P. This faint line is going to kind of represent my x-axis. Actually, maybe go a bit fainter than that, just to help you. There we are, there's my little faint line. And then what I can do is I'm just going to copy the original graph from this point. So something like this. And then y equals f of x plus 3. And I can mark that 3 there. P I can mark in here, it's gone up 3, so it's now 9, 6. And there we have our two graphs. Okay, and that should be enough there to get the full marks for the first part of the question. Part B says the graph of y equals f of 2x meets the graph of y equals f of x plus 3 at the point Q. So let's just think about it. F of x equals root x. So f of 2x equals the square root of 2x. And f of x plus 3 is going to be root x plus 3. So those are my graphs. Now where they meet or where they intersect would mean that I have root of 2x equals root of x plus 3. Now we're going to end up having to get a root x equals So while I probably was originally tempted to square it here, the fact I need to get it root x equals means that I shouldn't. So let's look at splitting up the root 2x. So that could be root 2 times root x equals root x plus 3. And let's get my root x's on one side. So I've got root 2 root x minus root x equals 3. And then let's factorize out the root x. And that will give me root 2 minus 1 equals 3. So root x equals 3 over root 2 minus 1. Now, this is a surd, and I'm going to need to rationalize it. So that means I need to times the top and bottom by root 2 plus 1. Now you can see that along the top I got 3 root 2 plus 1. And on the bottom I've got root 2 times root 2 is 2. And minus 1 times 1 is minus 1. So this is just my 3 root 2 plus 1, which is exactly what we wanted. So we've got our root x equals 3 brackets root 2 plus 1. Now finally we need to find the coordinates of Q. So easiest thing to do is think of substituting this into one of my equations. Now looking at both my equations, if I look at this one, I've already got a root x plus 3, so I can substitute this in to find that value of y. So my y value would be 3 root 2 plus 1 plus 3. So I've essentially got an x value and a y value, but I do need to simplify them. So let's sort out the y value first, and then we'll look at sorting out the x value. So the y value, we've got 3 root 2 plus 3 plus 3, 3 root 2 plus 6, or we can call that 3 brackets root 2 plus 2. And that can be our y value. Looking at our x, now for this I want to square both sides. So x equals 3 root 2 plus 1 squared. So I can do this in a couple of ways. I can expand the brackets, then do it. It's up to you, but let's do that. So we got 3 root 2 plus 3 squared. And if I'm squaring something, I square the first. So 3 root 2 is going to become 9 times 2, so that's 18. And then I square the last, and it's twice the product. So 3 times 3 root 2 is 9 root 2, so it's going to become 18 root 2. So you can see here I got 27 plus 18 root 2. And I could take a 9 out and leave it as 3 plus 2 root 2 as another option. So I would say that either of these now from here or the factorize should be fine for our coordinates of Q. So let's put that down. We've got Q is 9, 3 plus 2 root 2, comma 3, and it's root 2 plus 2. And there are my coordinates of Q. Okay, so we've got some differentiating and integrating to deal with here. So let's start with my f of x, my f prime of x, and that's ax minus 12x to the 1/3. Now if I differentiate this, it should and make it equal to 0, x is 27. So differentiating this, we get a minus, and then I've got a third times 12 is 4x to the minus 2/3. Now, we're told that this is true. So substituting this in, we get 0 equals a minus 4 times 27 to the minus 2/3. So let's change the sign, sort it out. 4 times 27 to the minus 2/3. So I can just go into my calculator here, but if you think of that 2/3, that'll put it on the bottom, the 27 on the bottom. You're cube rooting it for 3 and squaring it then for 9, so it should be 4 over 9. And I was just double checking on my calculator, but yeah, 4 over 9. So that is my value of A for the first part, part A. Nice and easy. Easy last question, I think. Now we need to find f of x. So let's look at our f prime of x. So that is 4/9 x minus 12x to the 1/3. This time we need to integrate. So if I'm integrating 4x over 9, I'm adding 1 to the power and dividing by that power. 12x, add 1 to the power, divide by that power. And then don't forget my plus c. So we've got 4 over 18, so that's going to be 2x squared over 9 minus, and then we got 12 divided by 4 and then multiplied by 3, so it's going to give me 9x to the 4/3 plus c. And that's my f of x so far. We need to find c. It tells me in the question that this curve passes through the point 1 minus 8. So f of 1, so 2 lots of 1 squared over 9 minus 9 times 1 to the 4/3 plus c, and then this should equal negative 8. So we've got 2/9 minus 9 plus c equals negative 8, and then I just need to rearrange, and that should give me 7 over 9 for c. So f of x equals 2x squared over 9 minus 9x to the power 4/3 plus 7 over 9. And that seemed like a really easy end. I think in general this paper was quite a nice paper. Some awkward numbers in it that certainly made me think whether I was doing it right at points. But in general, quite a nice paper. If you found some other ways of doing some of the questions, please leave them in the comments, because I'm always curious to see how people think about doing the questions and so on. So if you did a different method to me, please leave it in the comments, let me know. And if you do actually spot a mistake, as you know, I've gone through this paper quite quickly, hopefully I shouldn't have made a mistake, but there's always that chance. So if you do think you spotted a mistake, let me know so I can just double check it. And yeah, if you enjoyed the video, hit a thumbs up. You know, feel free to comment, as I've said, and if you're new to the channel, or if you've been here before but haven't subscribed yet, please consider subscribing for all the future videos. See you next time.